Good morning. My name is Annisa Nurulhuda. I am research student from Laboratory of Biosensing Engineering, Kyoto University. Today, the topic is detection of agricultural product quality, and my presentation will be based on this paper. This has published in Journal of Food Engineering in June 2004 and written by Ponkrit Maniwara et al. And the title is The Use of Visible and Near-Infrared Spectroscopy for Evaluating Passion Fruit Post-Harvest Quality. This is the outline of today's presentation. Like usual, I will start with introduction, then go through the conclusion. And this is the sample for those research. This is a passion fruit. Maybe some of you know this kind of fruit. This is cultivated in tropical and subtropical area. This fruit is considered highly commercial fruit, and nowadays the demand is increasing. Therefore, it is needed to find the method for predicting the quality of passion fruit. These days, non-destructive method for quality analysis is mostly by using spectrophotometry and image processing, so that we can get the internal quality of the product. And the most common used spectroscopy is near-infrared spectroscopy, since it is rapid and can give accurate result for the prediction. However, for this kind of fruit, the previous research used long-wave near-infrared spectroscopy, but they didn't get good results. So those researchers tried to make another approach by using visible and shortwave near-infrared spectroscopy for predicting the quality of this fruit. So this is the objective of the research, is to study the feasibility of visible and short-wave near-infrared spectrophotometry on post-harvest physicochemical quality evaluation. And the parameters are soluble solid contents, titratable acidity, absorbic acid content, ethanol concentration, pulp firmness, and pulp percentage. The sample for this research is taken from Niigata Prefecture in Japan, and then first they gather the spatial data acquisition by interactance and transmission using shortwave near-infrared spectrometry. Then after that, they used chemical and physical quality analysis. This is the schematic diagram of the research. The upper side is the diagram for interactance mode. So in interactance mode, the light source comes into the passion fruit and then interacted with the peel, pulp and other material inside, and then after that it is reflected back, and it goes, the unabsorbed light is reflected and goes into the detector in spectrophotometer, while in transmittance mode, the light goes into the peel and then goes to the pulp and the material inside the fruit, and the unabsorbed light is then transmitted to the detector. This is the result of the research. From the physical and chemical quality distribution, they get the average size of passion fruit for spectral measurement. And then the chemical quality analysis found out that the chemical quality distribution conformed to the previous research that they used as literature. And then this table shows the feasibility of visible and shortwave near-infrared spectroscopy application. From those parameters, almost all the parameters can be measured by using this kind of spectrophotometry except ascorbic acid content. And for the mode, for soluble solid content and titratable acidity, interactance mode gives better prediction result compared to transmittance mode. While for ethanol concentration, it gives another result. The transmittance gives better prediction result. While for pulp, peel firmness and pulp percentage, both modes give a insignificant difference in predicting the quality of passion fruit. So from the research, it can be concluded that visible and shortwave near-infrared spectroscopy is feasible for evaluating passion fruit post-harvest physicochemical quality. And the application of this instrumentation can be applied for another fruit that share the same physical quality with passion fruit. That's all the presentation today. Thank you very much for your attention.
Are there any questions? Okay.
Thank you for your presentation. Could you tell us maybe from the paper what range of wavelength was used? What range of wavelength was used for visible and maybe NIR, and maybe a graph would have helped to also show maybe the absorbance, transmittance also, maybe?
Actually, thank you for the question. For this visible and shortwave near-infrared, the wavelength used was 400 nanometer to 1000 nanometer. But for the previous result that get not very good prediction, the wavelength used was 1000 to 2500 nanometer. They didn't give any graph for the whole, so I couldn't answer. Sorry.
Are there any other questions? Are there any questions from NTU?
Thank you for your presentation. I would like to ask a question about the measurement of the ethanol concentration. So, how come the passion fruit has ethanol inside it?
The ethanol, thank you for the question. The ethanol concentration comes from the deformation of the fruit after sometimes after they harvested. The ethanol is formed inside the fruit, so it's kind of indicating that the inside part of the fruit has already some gets spoiled because of the post-harvesting process.
So the normal status, there is no ethanol inside the passion fruit, only it's spoiled out. Thank you.
I think it should be ethylene production, not ethanol.
Yeah, that's why it's not really.
Ethanol.
The research was not.
The right acid statement on the ethylene production.
If the peel can be transmitted by the light here, I think the peel is thick. So is the transmission works?
For the previous research, the radiation of the light couldn't penetrate into the peel thick. But for this shortwave near infrared, the radiation could penetrate into the peel of the fruit. The peel is quite thick, but it could penetrate into it.
I have questions for you. Among all the parameters, you mentioned that ascorbic acid content is not difficult to measure. Do you know the reason why?
In the paper, they said that the ascorbic acid content in the fruit is concentrated in some part inside in the pulp. So it's hard to measure the exact content of the ascorbic content.
Okay, thank you. Yeah, there's no more questions from NTU.
Thank you for your presentation.